My name is Robert Fischer, and this is my final project for Harvard CSCI E-29 called MOP. Now, MOP is an open source project that I've developed to help rein in, comprehend, understand cloud implementations. This project was inspired by the fact that I work for a Fortune 75 that has hundreds of implementations in major cloud providers such as Microsoft, Google, and AWS. And so this is designed to help rein in the chaos that has kind of been created in large organizations. Now, one of the things that public cloud does, and one of the reasons it's kind of an issue, is that it provides agility. So, infrastructure as a service, platform as a service, network as code, firewall as code, it allows change to happen at a very quick pace. And on top of that, there's not a lot of tried and true lessons learned because in part the platforms are changing so fast, and so really this uh, application framework is designed to um, rein in that agility and put governance in these implementations by making a system that can change as quickly as the cloud. Now, MOP seeks to comprehend your cloud, and it's going to be rolled out in three major phases. The first of two are already been partially released. So, first, it's going to use the cloud provider governance structures to identify defined governance failures. One of the things that I've learned through personal experience is that vendors that try to give a comprehensive view of your cloud assets across uh, one pane of glass often go to the least common denominator. Second is to develop analysis tools so we can combine multiple inputs from the cloud provider, provider governance structures, and also just scouring the um, the implementation itself, virtual networks, VMs, whatever. And then this is going to be the basis for input into it, applying a machine learning, right? So if we always have the cloud platforms changing, how are we going to get to the point where we actually can do machine learning? Well, MOP is a composable framework. It's designed for change. And as the cloud changes, so will MOP. So API methods are actually defined by a configuration file that is auto-generated. That means code generates our different API calls. And of course, the API calls, one of the nice things about the framework is that we take care of the security context for you. So what that means is we can take the addresses and drive the change as the change happens. Now, MOP is also flexible configuration. So these APIs are mapped into configuration files, again, that are machine created. And what that allows us to do is then release through the support models that we are thinking about, community support models, is that the changes can happen at any time. The other thing we do is we have an atomic write system where these configurations drive so much of the functionality. We make sure that your functionality is never lost by an update or change in the configuration files. Now remember, configuration files define the whole application. Okay, and we'll see. We use a plugin framework by which we can create various changes. Well, that framework is Pluggy. Okay, so MOP employs Pluggy, and that is the same framework that PyTest is built on. It gives us the ability to um, do a flexible composition where the analysis services that we want to capture and the APIs are all a pluggable attribute of MOP. And this pluggable modularity means that because everything is more atomic and configurable, it also lends itself to Apache Airflow and Luigi, right? Because these are atomic self-supporting actions. We can configure these actions on the fly. We can put them in the application wrappers. So what you can see here is that we are loading one of the APIs right here. And the definition comes from a configuration file. And what's nice is that we return not data, but a function. Okay. Now, what do we do once we have these results? Well, we have auto-generated storage. So everything inside of MOP is machine generated. And of course, that's storage. So what we do is we start with databases that are generated from code that could be shipped as part of a release or from community support. And then we use SQL Alchemy to generate the model code off of the database code that's auto-generated. So again, allowing us to speed up the speed with which the application can change. And of course, once you have data stores, we can use things like Power BI or what have you. So this library was built on a cookie cutter Python template, so it's on a good framework. The framework itself supports a lot of composition, employs a lot of context managers, and employs ORMs, all of which are subjects of the advanced Python course that we're in. So now let's do a brief code walkthrough that we can get an idea of how MOP is composed. First of all, what we have is the ability to have an ongoing, growing analysis, comprehension tool set for supplying eventually machine learning. As we said in the beginning, the goal here is to allow for machine learning by providing a lot of data from our public cloud providers, either Azure, AWS, or Google. Now, one of the ways that we're going to do that is through, first of all, configuration. We drive a lot of the functionality by composing what services are available. So the way that we do that is first we drive the services that are available, the APIs, through a configuration file. And you'll see that these are the APIs for Microsoft Azure services. Now, one of the things that makes this framework powerful is that it handles all the plumbing for authentication of these different services. You also notice that we can configure databases and carry other variables. And these things can be deployed incrementally and iteratively all the time. Now, one of the things that we do is we have atomic writes. But these atomic writes are a little bit different in that they put a version of the files that are generated. So you'll see here that we have these files which are generated to drive the application, and we also have older versions. So one of the things that we see going forward is the ability to have a support model where we just deliver a new configuration, and then that configuration will then drive the updating of the application. So kind of a very neat concept here. Now, the other way that we are able to do that, we have a very pluggable framework. We are using Pluggy, okay? And we'll go into that a little bit more. Now, the implementation here is not complete, but we're working towards that, and we've done some very successful, well, I've done some very successful trials of the Pluggy framework within this framework itself. So once we have the configuration of the various services that we're going to expose as functions, then what we do is we come and we call those as in a suite that's related to the topic. Now, one of the things that you'll notice is that we don't need to define these as individual methods. In reality, this one method here will allow us to call any of those URLs. Okay, it will pass in the arguments and the endpoint. It will handle the security context. It will close the connection. And the other thing is it returns an actual function. The .json is a method. And so what we're doing is we're returning a method that can be called later on in the application. Now, what you'll see here is that we are paying attention to policies, policy insights, policy states, and policy state resources, because what we're trying to do, what MOP is about, is gathering information about our cloud implementation. It's trying to gather information about it so that we can analyze it and feed it into our machine learning. And one of the things that I've learned, I've been working extensively with cloud for over 5 years, that a lot of vendors go to the least common denominator when it comes to governance. They take a very general approach, and I've found that it's better to work with the cloud vendor's own internal governance structures. And so that's the point of this application, is to move towards an easy way where comprehension can be done. Now, once we have that, we're going to want to necessarily cross-reference that. So the other thing we have is the ability to bring in resources from the architecture or the cloud implementation. So we have here just an example of this, where we're calling various web API endpoints. And again, with this very easily to configure architecture driven from that configuration file. Now, once we have that, then we might want to do some manipulations in, say, a database. Now, database is kind of the lowest common denominator right now. And the next data store, data analysis plane that we want to evaluate is using Gremlin or a graph database, where we can study the relationships between edge and node of these various entities within it. And so, well, what if we want to add a database? Well, here again we have a database definition. This is using SQL Alchemy, and SQL Alchemy is being put into play as a pluggy hook-in, right? So this database is being called basically as a plugin, and we see that here, where we actually demonstrate that we're just going to add this new database to our application by using the plugin manager. So what that means is that we can also configure multiple data stores very quickly. Now, the idea here is to take and make all these web API calls as plugins, and take and make all these database calls as plugins. And you can imagine that's a bit of work, and that's why we're still in alpha. However, we are currently doing the analysis proportion. So here's where I believe the business logic, the place for calling Luigi workflows, or calling Apache Airflow will take place, in that we will have these very atomic procedures that are configurable, that can be called as part of a workflow, either through a Luigi workflow or a Apache Airflow, and that then lends again itself to this learning comprehension framework that is pluggable, and therefore can allow for really good and rich community support as an open source project. It's that open architecture that I believe will make this a successful tool going forward.